Hello and welcome back, my fellow programmers. Today on the program, we are going to start Unit 5. We're going to start with Lesson 5.1, Anatomy of a Class. We are going to start with a class. We are going to dissect that class and see how all of the individual parts work, and then we are going to put that class back together. So we are all washed and scrubbed up and ready to start operating. Let's start the program. Our first topic is principles of OOP, our learning objective. Designate private visibility of instance variables to encapsulate the attributes of an object. Today we're going to be talking a lot about OOP. So we need to figure out what OOP is. Is OOP a fancy new diet? Is OOP a new product from Gwyneth Paltrow? Is OOP just a tiny little mistake? Well, it turns out OOP is actually an acronym for object-oriented programming. All that means is that we are going to be programming using objects. Imagine for a moment that you needed to walk from Chicago to New York. If you map that out, you would see that it would take you 296 hours to walk that 811 miles. That's a difficult task to do by yourself. So instead, you might employ an object to help you, like a car. And then using that object, that pre-built object, that will cut your trip down from 12 days to 12 hours. So using objects will help you accomplish that task. We do the same thing in programming. Sometimes we need to find the bigger of two numbers. We could rewrite all of that code every single time that we wanted to use it. That would take us 5 lines of code. Or we can just use a pre-existing object that already does that for us. That means object-oriented programming is going to be very beneficial to us. There are 4 principles of object-oriented programming that we want to follow. Now notice I didn't say that there are 4 rules of object-oriented programming. These are not rules. These are just principles that you should follow to make your life easier. You don't need to use any of the principles of object-oriented programming. You don't need to use object-oriented programming at all. We have written plenty of programs that do not adhere to object-oriented programming. But if you want to make your life easier, you should try to start adhering to these 4 principles. Now, the 4 principles are abstraction, encapsulation, inheritance, and polymorphism. Today, we're going to be focusing on the first 2 principles. That's abstraction and encapsulation. Focusing on that first principle, abstraction, we can apply that to a toaster. Now, there's a difference between how to use the toaster and how the toaster works. The toaster is very easy to use. You put in some bread, you push down a lever, and then it gives you toast. Now, how the toaster actually works is a mystery. Is there a little mini dragon in there that cooks your bread and turns it into toast? Is there a goblin down there that takes your bread and then exchanges it with a pile of toast that they have? I have no idea, and I don't need to know because of this idea of abstraction. The idea of abstraction is hiding that complexity away to make a complex item easy to use. Now, if you were really interested in how a toaster works, you could figure it out. It's not as exciting as having goblins or dragons living inside that box. So, the definition of abstraction is reducing complexity to increase efficiency, making something easier to use. It's the reason that we can make toast. It's the reason that we can use a cell phone, and it's the reason that we can drive a car, because all of the complicated parts of those tasks have been abstracted away. Our next principle of object-oriented programming is encapsulation. So, how many times have you put bread into your toaster, pushed down the lever, and just a bunch of flames came shooting out of the top? Probably not very often. The reason for that is encapsulation. You are not allowed to change the inner workings of a toaster. The toaster has been made to only work within safe operating procedures. You cannot turn up the heat high enough for that toaster to then just spit out flames. So, parts of encapsulation is that the toaster has a protective shell to keep you away from the insides from messing up any of those complex pieces of machinery in there. It also has a knob with settings that allow you to change some of those operating values, but you can only change them within safe boundaries. You can only turn the heat down so low, and you can only turn the heat up so high. That's not the hottest a toaster can get, but it's the hottest that they will allow you to have the toaster to get. So that protective shell protects the inner equipment from you, the user, from messing with anything that you shouldn't be messing with. And that knob with the settings only allows you to change the settings within safe parameters. So the definition for encapsulation, we are going to be protecting our variables, our constructors, and our methods from misuse. We see encapsulation in the real world, like we said, the toaster has a cover with only a lever and knobs. A car engine is stored safely under the hood, and a cell phone is covered with only 3 buttons. This aligns with our essential knowledge. Data encapsulation is a technique in which the implementation details of a class are kept hidden from the user. Our next topic is access modifiers, our learning objectives. We want to designate access and visibility constraints to classes, data, constructors, and methods. And we have a second learning objective, designate private visibility of instance variables to encapsulate the attributes of an object. Before we get into our access modifiers, we are going to have a brief review of these sections of a class. We've covered these in our Unit 2 videos, but we are going to go over them again. In the code on line 1, you will see that class definition, public class die, and then an opening curly. So this is going to be a class that defines a singular die. Looking inside that class, the first section that we see is the member variable sections. In this case, we have 2 member variables, one to indicate how many sides that die has. Is it a 6-sided die? Is it a 12-sided die? Is it a 20-sided die? And then we also have a string to indicate the color of that die. Looking at line 6, that's where the next section of the class starts. That's our constructor. We have 2 different constructors, one that starts on line 7. It is a constructor that takes no parameters, and it sets the number of sides to 6, and it sets the color to red. So a classic red 6-sided dice. We have a second constructor where you can specify how many sides you want for your die and what color you want your die to be. All the way down on line 17, that's our third section of a class. That is the methods section. And in here right now, we only have one method, which is to roll the die. We're going to pick a random number between 1 and the number of sides that is stored in the member variable, and then we are going to return that result. Now we see our access modifiers all throughout this class. We just need to figure out what they are and what they mean. In order to get a better handle on what an access modifier is, we're going to think about a place to store books. There are 2 good places to store books. One of them would be a library, and the other one would be your house. Now, these are 2 very different locations in which to store books. The library is a public location. Anyone can go in and see and read the books in that library. Now, your house is going to be a private residence, and only the people that live there can go in and see and read the books. So, understanding the difference between a public location and a private location is important to understanding what access modifiers are. The definition that we will be using for access modifiers is keywords that set accessibility of variables, constructors, and methods. We are going to have 2 different access modifiers. The first one being public. That is a keyword that makes variables, constructors, or methods accessible from outside of the class. The keyword private is a keyword that makes variables, constructors, or methods accessible from only inside the class. This aligns with our essential knowledge. The keywords public and private affect the access of classes, data, constructors, and methods, and the keyword private restricts access to the declaring class, while the keyword public allows access from classes outside the declaring class. So, just as a brief overview of all of the vocabulary terms that we've been talking about so far, we have our 4 principles of object oriented programming: abstraction, encapsulation, inheritance, and polymorphism. We have our 3 sections of our class: our member variables, our constructors, and our methods. And we have 2 access modifiers: public and private. The first thing that we're going to be looking at is the class definition in general. Now, the class definition will have an access modifier of public. As we talk about access modifiers, this deals with our principle of object-oriented programming of encapsulation. Again, encapsulation means protecting our class, variables, constructors, and methods from misuse. We're talking about the overall class definition, and we are going to give that the access modifier of public. We do this so that other classes can use this class and make objects from it. It wouldn't do much good if we made a class and nobody could use it. If we only made it private to the class itself, nobody then could create any die objects from this class. This aligns with our learning objective: classes are designated public. Also, data encapsulation is a technique in which the implementation details of a class are kept hidden from the user. And when designing a class, programmers make decisions about what data to make accessible and modifiable from an external class. Data can be either accessible or modifiable, or it can be both or neither. As we start to look into that class, the first section that we see in our class is going to be our member variables. Our member variables make up our instance variables. Our instance variables are non-static member variables defined in a class. We are going to declare our instance variables as private. So for a die class, we're going to have a number of sides. That's going to be an integer. And we are going to keep that private so that people outside of the class cannot access that directly. We are also going to have a color, which we are going to declare as a string, and we are going to keep that private to inside this class. So we'll have 2 files when we are creating this program. We will have our main.java, where we put our main method, and then we will have our die.java, which we will have all of the code for our die class. Now, the main.java can still create die objects. They just cannot access the sides variable and the color variable directly. For the die class, the constructors and methods will all have access to these variables. It is private to this file only, so everything in this file will have access to them. We don't want to give direct access to outside of the class because our class depends on having correct data in these variables. Now, if a user tried to put a negative number inside, that could mess with our constructor, that could mess with our methods. So we want to make sure that we protect these variables and that we are only putting in clean data into them. So we are not going to give direct access to the outside. We will keep these under our control. This aligns with our essential knowledge. Access to attributes should be kept internal to the class. Therefore, instance variables are designated as private. Instance variables are encapsulated by using the private access modifier. Again, this is that principle of object-oriented programming: encapsulation, protecting our variables from misuse by the user. Going on to our next section of the class, we have our constructor. The definition of a constructor: a special method of a class that instantiates an object of that type. In our example on the top right, you can see that we have one constructor that takes no parameters. It will assign the number 6 to the variable sides, and it will assign the string value of red to the variable color. Our constructor is declared as public. We want another class to be able to call this constructor. We want the user of this class to be able to construct an object from this class. That means in our main.java, they can create a die object because they have access to the die constructor because it is public. It can be seen outside of the die.java file. Inside the die.java file, we are saying my constructors are open for public use. Anybody can create a die object. This aligns with our essential knowledge. Constructors are designated public. Moving on to our third section of a class, the methods. A method is a function associated with an object. Looking in our example, we can see our methods section in which we have one method called roll, in which we will return an int, and then we are going to generate that roll and return it to the user. Now, this method is declared as public, but not all methods are going to be public. Some methods will be public and some methods will be private. This aligns with our learning objective. Access to behaviors can be internal or external to the class. Therefore, methods can be designated as either public or private. That is because we don't just lump them all into a category called methods. We break them down into 4 different subsets of methods. We have our class-specific methods, our getter methods, our setter methods, and our helper methods. Looking first at class-specific methods, methods built specifically for this class. Now, for the die class, we have a roll method that's made specifically for the die class because that's what you do with dice. You roll them. It wouldn't make sense to have a roll method in our toaster class because you don't roll a toaster. The class specific methods for the toaster would be something like toast. Class specific methods should be public. The reason we make the class is so that other people can use the class and do those class-specific actions. We want somebody from a different class to be able to create a die object, and we want them to access the roll method. Still, inside that die.java file, everybody in there still also has access to that method. The constructors, the other methods, everybody can access roll, even if it was private. Everybody in that class, the constructors, the methods, they could access that roll. It doesn't matter if it's public or private. Inside the class, we'll be able to see it. The next category of methods that we're going to be talking about is getter methods, or we also call those accessor methods. It is a method that returns the value of a private instance variable. We can see on line 2, we made a private variable called sides, and we said very specifically, we are going to make that private to protect the integrity of that data. Well, whoever uses this class might need to know the number of sides a die has. So we are going to write them a method that specifically gets them the number of sides. That's the whole point of this method, is just to return sides to the user. Therefore, the user doesn't have direct access to the variable, but we will tell them the value if they ask for it. Those getter methods should be declared public. It is the only way for an outside class to get the value of one of the member variables. So the main.java can create a die object, and it can access the getSides method, in which it will get the value from sides but still not have direct access to the variable sides. In the die class, anybody can call getSides, even if it was private, because it's still in the same class. This aligns with our learning objective. The provided accessor and mutator methods in a class allow client code to use and modify data. Well, contrary to the getter method, we are going to have a setter method, which we call a mutator. This is a method that is used to change the value of a private variable. You can see in our example on line 2, we have a method called setSides, in which the user can give us the number of sides that they want. Now, we are not just going to put that into our private variable sides. We want to make sure that it is within a certain set limit. So we want to make sure that the sides they give us is greater than 0 and less than or equal to 100. We don't want them to make a zero-sided dice. We don't want them to make a die with negative sides, and we don't want them to make a die with more than 100 sides. So we are going to make sure that that data is good, clean data, and then we will put it into that instance variable sides for them. Otherwise, they're just going to be stuck with a 6-sided die. This mutator method or setter method should be given the access modifier of public. We do want them to use this outside of the class because it's the only way they can change the value of those instance variables. So outside of the class, they can create a die object and they have access to the setSides method, and everybody inside the die.java file has access to the setSides method. This aligns with our learning objective. The provided accessor and mutator methods in a class allow client code to use and modify data. Our fourth and final type of method is a helper method. That is a method that performs internal tasks for a class. In our class, you can see we wrote a method that tests rolls, so it will roll the die 100 times. This might be something that we use for internal testing, just to make sure if we were picking a random number between 1 and 6, we want to make sure that we hit that number 1. We want to make sure that we hit that number 6. We want to test the ends, the bounds of that, and we want to make sure there's a pretty even distribution of those numbers. So we wrote this as an internal test to help us. We don't want the user to have access to this. This is just for us as the writer of the class. So we are going to make our helper methods private. That way, outside of the class, they can still make a die object, but they don't have access to this very specific method that we wrote. But inside the class, everything inside the class has access to that test rolls method. This is going to bring us to the end of our lesson. Make sure you rate how you feel about those learning objectives. Read over your recap statements. Hit me up with any questions or concerns that you have regarding this content. Join us in our next video and keep programming.